Today we're going to look at substring search algorithms. This is a really fascinating family of algorithms. The problem is very simple to state, and the algorithms we're going to look at are among the most ingenious that we've seen so far. So as usual, I'll introduce the problem. A very simple to state problem. We have two strings. One we call the pattern, and the other we call the text. And usually it's good to think of the pattern as relatively small and the text as relatively long. In fact, usually we want to think of the text of unlimited length coming in on an input stream. And we have a small pattern. We're trying to find out if the pattern occurs in the text. So you're doing this all the time when you do a simple search on your computer or on the web. And there's practical applications where for various reasons people want to search the entire contents of memory or disk for a particular pattern to make sure to check for whether there's something on the computer that's of interest. And again, that's such an application, you've got a small pattern and maybe a huge text. Or maybe you're looking through your email, which you can think of as a continuous stream of stuff coming in nowadays, and you want to look for patterns that might indicate that there's spam. And certainly you're all familiar with these types of patterns. So what we want is to be able to identify the pattern quickly and efficiently in a huge text file. That's one of the most important indicators of spam, I guess. Okay, so we'll try to set this up. This isn't really a real situation, but it's not too far, actually. And so we have these characters to try to point out the kinds of issues that might be involved. So imagine an internet surveillance situation where there's a need to monitor what's on the internet for reasons of security. But there might be a judge saying, wait a minute, you can't be looking at all internet traffic. That's private information, particularly among private individuals in the U.S., for example. Well, so what about if we just look for this one pattern that we really need to know about and that really shouldn't violate anybody's privacy, like attack at dawn. And the judge can say, okay, how about if you build a machine that just looks for that? And that's what we're going to talk about today. Actually, one of the techniques that we look at is perfect for actually building hardware that can be put on a stream of data passing by and just light the light if that particular pattern is seen. So you attach one of those machines all over the web, and if attack at dawn happens, then you find it. That's say a simplified explanation of what it is that we're going to try to do. Here's another kind of application. This is called screen scraping. So we might want to, and you can do this, write programs to do this for extracting relevant data from a web page. And the idea is that there's different institutions out there that are committed to providing information on the web, and they'll promise to, for example, this is Yahoo's page that gives the stock price of Google. When you look at the page, it says last trade. But if you write a program to look at the code that produces the page, it also says last trade. And since this HTML code is produced by a program, it's always going to have the same structure. So if we want to write a program to find Google's stock price at any time, what we can do is take this page, put it on an input stream, and search for the pattern last trade. And then just after last trade, there's the price in bold. So what we really want is the string between B and \B, which delimits bold, after the first occurrence of the pattern last trade. And it's simple to write a Java program that implements this. This is the program, and the key is Well, number one, our standard input stream methods allow a web page as argument. So in this case, we provide a command line argument, which is whatever company you want the quote for, and we simply read in the whole web page. So now you have the web page in a long string, and then Java has a index of method for every string, and it tells you where that particular string occurs. And so we'll start at index of last trade, and then what we want to do is find the first B in brackets after that position, and the first being closed with / B in brackets starting from that position, and skipping over the angle bracket B closed bracket, you get the price and you can print it out. And now this is a little utility that screen scrapes from Yahoo's website. So substring searching is quite useful, and it's built in as a method in Java's string data type. So it's practically useful. That's an introduction. So now let's look at algorithms for implementing string searching.